All right, guys, let's finish up this lesson. So what our concept is that we're trying to go over today for this part is we're going to write intervals with a starting value, comma, and ending value with parentheses or brackets. The parentheses say get really close, like an open circle. A bracket says count the number like a closed circle. A lot of these are going to have infinity as a beginning or an end point, and infinities always get parentheses. All right, so we're going to solve this one. I'm going to subtract the 2. Divide by -5. And because I divided by a negative value, I have to switch my inequality. So I'm going to have a bracket going to the left for less than. So I'm going to start at negative infinity, comma, stop at -3. Infinities always get parentheses because they're not really a number because it keeps going. But I'm going to count 3 because it's a bracket. -3 and everything to the left of it. All right, this next one, we're going to solve. We're not going to take it apart. We're going to solve it as it is. So to solve this, I'm going to multiply all 3 sides by 2. I'm going to subtract a 3. And as we go through these, if I'm moving too fast, pause it every once in a while. I'm going to work to get it done. You can pause it as you need to. All right, this one is a little different. All right, this is compound inequality. What this says is I'm going to want all the x values between -3 and 7. But I want to count -3, and I don't want to count 7. So we're going to think this is a between. I want the x values that work in both of those. So I'm going to go -3 and 7. I'm going to put a bracket on -3, a parentheses on 7, and I'm going to ask for everything in between, because all the numbers, if we talk only integers, -2, -1, 0, 1, 2, 3, all these, and all the decimals in between will make this work. So this interval is going to be from -3 to 7, counting -3, getting close to 7. So don't take that one apart. Solve it as it is. All right, absolute value inequalities. This is either going to be an and statement or an or statement. So what I'm going to do first is I'm going to divide both sides by 2. And then I'm going to solve this. Absolute value, we get 2 equations. Inequalities, 2 inequalities. 3x minus 4 is greater than or equal to 5. My second one is going to be 3x minus 4 is less than or equal to -5. We switch the inequality, we switch the sign. We switch the right side. All right, so now I need a word, one of those between these 2 inequalities. I'm going to read this as a greater symbol. Greater or symbol. That tells me it's an or symbol, or problem. If it's a less than, I'm going to read it as less than, which would be an and statement. So I'm going to put or. I'm going to solve both. I'm going to graph both. So greater than or equal to 3, less than or equal to -1/3. All right, this is the same lesson I'm teaching in Algebra 2 today, or I taught in Algebra 2. The idea is if it's an or statement, I need all the answers I can get. An or statement, I want all of this. So I'm going to write 2 inequalities. I'm going to go from -infinity to -1/3, parentheses, bracket, then bracket 3 to infinity. And I left the space in between for a reason. So what I want to do is I want to take both of these inequalities and stick them together. Put them together into one set of numbers. And what we're going to do is we're going to put a U between them. That's called the union. The union takes two sets of numbers that don't intersect, they don't have anything in common, and kind of puts them into one. So this is going to be our answer. If you don't write the U between it, I'm going to be okay, and I'll understand. But we got to recognize when we do this, if the back of the book or somewhere else has a U in it, that's putting two sets of numbers together. All right, so great OR, an OR statement, I want everything. You only have to satisfy one of them. All right, if this was an AND, let's say if I wrote one that was an AND that looked like this, my AND statement, remember, I need what they have in common. And I would write an inequality that deals with the numbers that they have in common. An OR statement, give me everything. An AND statement, tell me where they intersect. And that would be the interval where they intersect. All right, domain. Domain is going to be an issue that we're going to have to deal with a lot. There's something called implied domain. It's what we need to be able to look at a function and tell what the domain is. All right? So, we have two situations as of today where we need to worry about domain. A rational function is a fraction. So, we know when we're dealing with fractions, that we are not allowed to have 0 in my denominator. All right, so when I have a rational function, your denominator cannot equal 0. All right, the second situation is a radical function. And all we're going to worry about are even roots. Square roots, fourth roots, 10th roots, and the same. If I have an even root, our radicand, what's underneath, has to be greater than or equal to 0. The reason is, square root of 4 we know is 2. Square root of 0, 1 times itself gives me 0. Okay, that's 0. Square root of negative 4 isn't a real number. That's not real. That's why we would have said before 2i. All right, so what we take the square root of, the fourth root of, the 10th root of, has to be greater than or equal to 0. If it's not, when we're talking domain, we're not going to worry about it. It can't be done. All right, so for number 11, I have a rational function. So my denominator cannot equal 0. So I'm going to write that equation. X plus 4 cannot be 0. So that means x cannot be negative 4. And we're going to say that's our domain. X is every single number will work except negative 4, because negative 4 is going to give me a denominator of 0. So anytime we see a rational function, we're going to set our denominator not equal to 0 and solve it. All right, for number 12, I have an even root. The square root of x minus 8. So it's a radical function, so I need to look at this. Even root, yes. What I have underneath has to be greater than or equal to 0. Whatever is underneath an even root has to be greater than or equal to 0, because we need it to be a 0 or a positive value. It cannot be negative. So I'm going to say that x has to be greater than or equal to 8. If I want to write an interval, I do bracket 8 comma infinity parentheses, because this would be that graph. So I can put 8 into here. That's square root of 0. I can put 9 into here. That's the square root of 1. But I can't put 7 because that's the square root of negative 1. So I can put 8 in any number larger than 8. So what's underneath an even root has to be greater than or equal to 0. All right, number 13. G of x is x squared plus 1. G of x is x squared plus 1. So I'm going to go back. Is this a rational function where I have a fraction? It's not. Is this a radical? And that's not. So automatically, We're going to say it's all real numbers. All right? So with all real numbers, if we want to, goes left and right forever, I can say from negative infinity to infinity, parentheses, parentheses. Same thing. So I want to show you different ways that they can write these answers. So the back of the book may say this, it may say this, all depending on how they decided to write it. All right, the next one. H of x is 2x over 4x plus 9. Well, I have a rational, which tells me my denominator is not allowed to be 0. It can be anything else I want, but it can't be 0. So my domain is going to be all real numbers except negative 9/4. Because if I put a negative 9/4 into these two, I'm going to get some number over 0, which is not good, because we're not allowed to divide by 0. All right, last one, I believe. Yep. P of x is the cube root of x plus 1. Q of x is the cube root of x plus 1, so it's not rational, but it is radical. I do have a radical function, but I'm going to step back and say the radical function's even roots have to be greater than or equal to 0 underneath. But I have an odd root. Since it's odd, it's all real numbers. I don't care. If it's the third root, the 13th root, the 131st root of something, I can put any, because we're going to look at this. Cube root of negative 8, what times itself, it gives me negative 8. That works. That's negative 2. Cube root of 0 is 0. And the cube root of positive 8 is a positive 2. So it doesn't matter. You can take the cube root of any number you want, but you can't take the square root, 4th root, 24th root of anything. If this was the, let me erase something real quick. The 30th root, I would have to say that x plus 1 has to be greater than or equal to 0 and so on. But since it's just the third root, it's all real numbers. All right, last part. I'm not going quick. Let's just say pause it if you need to. All right, the difference quotient. This is going to set us up for a lot of stuff. And when you get to calculus, if you get to calculus, this is a very important concept. All right, so what I'm going to ask you to do is evaluate this using the difference quotient. The difference quotient says f of x plus h minus f of x all divided by h. And we're going to do something, and hopefully this helps. All right, we're going to start with the same function just to get an idea across. If I wanted f of 3, hopefully we all know plug in 3. If I want f of 7 or 23, I'm going to 23. If I want f of q, I'm going to put in q. If I want f of a smiley face, I'm going to plug in a smiley face. It doesn't matter what's in there. So if I want f of x plus h, in the place of x, I'm going to put x plus h. And evaluate. As easy as that. F of an elephant is going to be 2 times an elephant plus 3. All right, so it doesn't matter. All right, so this is what we're going to use. We're going to do it in like a couple pieces. All right, so I'm going to work on this first. This is my function. I want f of x plus h. So I'm going to take that x plus h and plug it into here. And I'm going to put brackets around it, not the same brackets as before, just to separate it. All right, so f of x plus h, when this is f of x, is 2 times x plus h plus 3. All right, now, they want you to subtract f of x, which is just that, the original function. And then lastly, divided by h. So I do it individually. I'm going to find f of x plus h. Put it in this first bracket. Then I'm going to subtract the original function f of x and divide it by h. And now I'm going to evaluate. I'm going to distribute. I'm also going to distribute the negative sign back here. And then lastly, I'm going to divide it by h. All right, so I'm going to add like terms. 2x minus 2x, that's a good thing. 3 minus 3, that's a good thing. And I'm left with 2h over h. So this is all I have left. Everything else canceled, which is just 2. And that's your answer. So piece by piece, find me f of x plus h by plugging in x plus h. Then subtract the original function. Divided by h. Clean up the inside. Clean it up, distribute the negative sign, and go from there. This f of x plus h is just as easy as f of 3 and f of 2 and f of a happy face, just like that. Same idea. All right, last one. Get rid of this. All right, f of x is x squared minus 2x minus 4. So I'm going to ask you to do the difference quotient. And using this function, I'm going to erase this, but if I wanted f of 3, we're going to do 3 squared minus 2 times 3 plus 4 to evaluate. So I got to put it in both places. All right, so try to color code this. All right, so f of x plus h. I'm going to go x plus h squared minus 2 times x plus h plus 4. Because to do this, I have to put x plus h in both of those places. Then I'm going to subtract the original function. All divided by h. Come over here. X plus h squared is the same as x plus h times x plus h. FOIL. That's what I'm going to get. You guys, if you had me last year, may have remembered, when you have a parentheses square, you square the first term, you square the last term, you multiply them together, and then double. But that's just a FOIL. You've got to be able to FOIL that. Don't just square each piece, FOIL it. Then we distribute and get all of that. Then, this back one, I'm going to distribute that negative sign into everything. All over h. All right, as we do these now, once I clean up all that top, or I distribute and do all the stuff on the top, the rule needs to be if it does not have an h in it, if there's no h in it, it needs to disappear. And I'll show you, x squared minus x squared is gone. That has an h in it, so it's going to stay, has an h in it. Negative 2x plus 2x, gone. Positive 4, negative 4, gone. So I'm left with 2xh plus h squared minus 2h all over h. If it has an h in it, it's not going to disappear. If it doesn't, it's got to go. All right, lastly, all of these have an h, so I'm going to simplify and take it out. 2x plus h minus 2. And that's the difference quotient solution. So this problem is all about the algebra. If we can get the algebra right, we're going to be good. If we can't get the algebra, we're going to struggle. So you got to be able to ask questions and get some help. All right, so that's the lesson. I'm going to post. This will be posted with the homework. If you need help, talk to me, contact me, come on Friday, do something. Don't wait till class and say, I don't know how to do it. Little late. All right? Come early, come talk to me, let me know what's going on. All right, have a great day.